Second International Physics Olympiad, year 1968, IPHO. Problem number 1. On an inclined plane of 30 degrees, a block mass m2 equal 4 kg is joined by a light cord to a solid cylinder. Mass m1 equal 8 kg, radius r equal 5 cm. Find the acceleration of the bodies are released. The coefficient of friction between the block and the inclined plane μ equal 0.2. Friction at the bearing and the rolling friction are negligible. Solution for problem number 1. First, let's draw the free body diagram. So in this diagram we have forces acting on this cylinder and the block. If the cord is stressed, the cylinder and the block are moving with the same acceleration a. Let F be the tension in the cord, S the frictional force between the cylinder and the inclined plane. The angular acceleration of the cylinder is a over r, because there are no sliding. The net force causing the acceleration of the block is this one. m2a equal m2g sine alpha plus force F and minus force of friction, which is mu m2g cosine alpha. And the net force causing the acceleration of the cylinder is this one. The equation of motion for the rotation of cylinder is I beta equal SR, where I is moment of inertia for cylinder, which is 1/2 m1 r square. Beta is angular acceleration, which is a over r, and the S is force of friction for the cylinder. So from this equation, putting this expression, we have 1/2 m1a equal force S. And now we can put this expression for S to the second equation, and we have this one. Now we have first equation and this equation, and we can exclude force F, just adding these two equations. Finally, solving all these three equations, this, and this, we can find that acceleration equal this expression, which is about 3.25 meters per second square. Force S equal this expression, which is about 13.01 Newton, and the stretching force between block and cylinder is this one, which is about 0.192 newtons, which is very small, but it's still positive. Now let's investigate what happened in critical positions. For the system start to move, we have acceleration must be greater than 0, and from this formula we have tangent alpha equal this expression, which is 0.0667, and the critical angle is 3.81 degrees. For cylinder to move, we just have angle alpha must be greater than 0, and for block separately to move, we have tangent alpha must be greater than mu. It means that alpha is 11.31 degrees. Tangent alpha greater than mu, and the critical angle is 11.31 degrees. If the cord is not stretched, both bodies move separately, and the critical angle for that when F equal 0. It means that tangent alpha equal 3 mu or 0.6, and the critical angle is 30.96 degrees, which is slightly greater than our original angle 30 degrees. So, and after this critical angle, they will move separately. Basically, we finished discussion for problem number 1. So we found what is acceleration. That was 3.25 meters per second square. We found that force F is a stretching force. It means that both bodies move together, and our angle slightly less than critical angle for which these bodies move separately. So that was solution for problem number 1. Second International Physics Olympiad, year 1968, IPHO. Problem number 2. There are 300 cubic centimeters of toluene of 0 degrees Celsius temperature in a glass that, and 110 cubic centimeters toluene degrees Celsius temperature in another glass. The sum of the volumes is 410 cubic centimeters. Find the final volume after the two liquids are mixed. The coefficient of volume expansion of toluene beta equal 0.001 degree Celsius in power -1. Neglect the loss of heat. Solution for problem number 2. First, we can calculate what is temperature of the final mix. That will be this one. We don't know yet what is M1 and M2, but we can count them using density for final mix. That will be M1 equal this expression and M2 equal this expression. Now we can put these expressions to our formula for final temperature. That will be this one, and from here we can find the final temperature. So we have equation like this. This is quadratic equation to T, and using new parameters A and B we can rewrite it in more compact form. If we choose now A equal V1 plus V2 and B equal V1 T1 plus V2 T2, we have this quadratic equation, and this equation has two roots. One root is negative, which we don't need, and other is positive, which is T equal B over A, which is this one. Exactly as this formula, but for masses, not for volumes. Now we can count what is final volume, which is this expression, and after using T from here and insert it here, we can find that volume V equal just V1 plus V2, which is initial volume for both parts. That's 410 cubic centimeters. So here we found that any mix of the same matter will not change the total volume. That was solution for problem number 2. Solution for second International Physics Olympiad, year 1968, APHO. Problem number 3. Parallel light has are falling on the plane surface of a semi-cylinder made of glass at the end of 45 degrees in such a plane with it's perpendicular to the axis of the semicircular figure. Index of refraction is m equal to square root from 2. There are rays emerging out of the cylindrical surface. Solution for problem number 3. Let us use angle phi to describe the position of the rays in the glass. According to the law of refraction, we have sine 45 degrees equal sine beta multiplied by square root from 2, which give us sine beta equal 1 over 2 and the beta equal 30 degrees. The refracted angle is 30 degrees for all of the incoming rays. We have to investigate what happens if phi changes from 0 to 180. It is easy to see that phi cannot be less than 60 degrees, because OAC is 60 degrees and all three angles are 60 degrees. The critical angle is given by sine beta equal 1 over n. It means that beta equal 45 degrees. So we have OCA is 45 degrees and OAC is 60 degrees. So finally we have phi equal 180 minus this 60 and minus this 45, which is 75 degrees. If phi is more than 75, the rays can emerge the cylinder. Increasing the angle, we reach the critical angle again when we have OED 45 degrees, and also we have angle ODE, which is 80 plus 30. So finally we have 45 plus 90 plus 30, which is 165. This is the ray leaving the glass cylinder if SE, arc of the emerging ray, substance central angle of 90 degrees. And our angle belongs to difference between 75 and 165, which is 90 degrees. This is COE. That was a solution for problem number 3.